So welcome back. This might be a part two. I might splice this together. We ran out of time in the first Zoom. I'm joined again with Bill and Nick Cellini. We're talking about whether you need to have a three-phase supply for your heat pump, or if you can get away with it on a single phase. I want to talk about single phase, Nick, because I think most of Europe is three phase. Now, have I got this right? It was all this phase malarkey, something to do with Edison and Tesla back in the day. I mean,
oh, crikey, I'm going to pass that one on to Bill.
Oh, thanks. Thank you. It's basically because you mentioned Edison and Tesla. Their argument was between DC and AC. AC was chosen as the preferred method of delivering electricity in the early days because there are some danger issues with DC, and Edison was very good at winning arguments and convincing people. He was an out-and-out showman, whereas Tesla was a bit of a recluse. He was just the engineer who just wanted to get on with it. AC causes problems because there are limits to what you can actually push down how far you can send the current down the cable, because you start losing frequency. The difference is that you're providing the power as the current and the voltage alternate between two peaks, a plus peak and a minus peak, and they pass through zero. And it's been decided that across Europe we operate at 50 hertz. Now that's 50 times a second. The voltage rises and falls, passes through zero, back to zero, 50 times per second. So the electrons are going backwards and forwards down the line. They're not traveling along it altogether, they're just going backwards and forwards, and that provides the energy. Now, what you can do is send extra down the same wire. You can overlay three phases along the same wire and transmit more power than the single phase down the same piece of wire for more or less the same amps. So you get more power but keeping the amps lower. So you get less heating in the wire. It gets a little bit difficult to explain to somebody who's not seen done the whole thing. But it's basically we adopted single phase in the first days because in the 1920s, when they developed our electrical grid, the only electrical power you needed was a light hanging from the ceiling. We didn't use it for much else, so we just used single phase. It was fine for a long time. Most of Europe replaced their electrical grid after the Second World War because most of it was destroyed. By then, people are using washing machines and vacuum cleaners, electric cookers, all sorts of electric. So they realized the potential for putting in three-phase rather than single-phase. I think Italy is the other country in Europe that uses single-phase like we do. France has a novel system. It uses single, two, and three-phase. As the Americans use two phases as well.
And the Americans are 60 hertz as well, I believe. I mean, I think
they're operating 60 hertz. They have two phases at 110 volts. But when they put the two phases together and use them on the bigger equipment, that makes 240 volts. We put three phases together, that adds up to 400 volts. It's actually about 440.
We were talking, obviously, at the beginning of this program whether people need three phases to hit their heat pumps, and I think we came to a decision, not necessarily, but obviously there's going to be times when you do. Now, what an interesting thing I think listeners will also want to know is when you put a heat pump in, do you have to actually notify anyone to do with the electrical companies? I mean, it's interesting because when we put instantaneous showers in this industry, let's say you've got a 9.5 kilowatt shower, that's a lot of fucking, that's a lot of watts. And let's say you've got 4 en suites. I don't know where you might have 4 en suites, and then you go and bung 4 9.5 kilowatt showers in, that's
But there
pulling
is,
awful
but
lot of
you
amperage,
do,
isn't it?
there is a way that this has to be notified under the Part P building regulations.
Yeah.
And that this has to be the electrician who's installing it has to fill in all the forms.
They don't always get
And-
installed by electricians, if I can tell you that.
No, this is where things start to go wrong. But if it's done correctly, the Part P electrician fills the forms. He completes his forms, and by filling in the forms correctly, he'll be able to work out whether the load is suitable for the supply. And then he submits that to the building control at the local council, and it's recorded. I believe then that they make that available to the DNOs, so the DNO can see what's connected.
Just describe
via
what
the
DNO
Part
is
P.
for the lay person that listens to this. Just describe what the DNO is.
It's the organisation that looks after the cables that supply the power from the main national grid to your house. So all the if you've got overhead cables that you can see in the street, those are operated by the DNO. Most towns, they're underground. The cable comes up in the house and is connected to your meter. So you don't see an awful lot of it. But here in the West and in Wales, it's Western Power. But I can't remember how many there are. It's about 8 or 10 around the country. And they are basically the privatized local electricity boards that used to be around. Now their remit is merely to provide the cables for the transmission of the power. They don't supply power. Now that they're not allowed to supply power, which is why they are changing to a DSO. And their legal status is going to change so that they are allowed to put electricity onto the grid themselves. That will enable them to use batteries to balance the voltage and frequency on their local networks. And that's a bit of a game changer.
Yeah, we had a battery show the other day, and I'm actually going to be speaking to some of my participants that joined me for that Zoom meeting this Friday. So I'll be doing a bit of a battery theme. So, Nick, we were talking about your 20 kilowatt units that can go in on single phase. Just sort of reiterate that again, just so that sort of gets in people's minds.
Yeah, so it take us right back to the initial building heat loss calculation, essentially. So you carry out the heat loss calculation at the given outdoor design air temperature -3. Let's say if it's a sizable property with relatively large heat loss, that's 20 kilowatts, to be honest. And it needed that capacity. We have a single phase unit available. That unit will use approximately 5 to 6 kilowatts of electrical energy to run at peak. And you mentioned earlier electric power showers that are running at 9, 10 kilowatts. Now we're using just over half that energy to heat the whole of the house. And
that's a big house. I mean, I've got a friend.
Yeah, so that is a big house. Yes.
I've got a friend who say, if it's 20 kilowatts, that's a 20-room house.
That's a mansion.
The average homes apparently are between 6 and 10 kilowatts.
It is, yeah. But just we just on the heating capacity as well, we've supplied many systems with 2 single phase units connected together in cascade, so providing 44 kilowatts in peak thermal output on 1 single phase supply. And 44 kilowatts is a very big house.
That's a castle, Nick.
Yeah.
You've got a few.
There's not too many. There's not too many of them have been supplied, but
you've got a few of them in Wales.
It's a solution that's available, and the manufacturers that don't have larger capacity units, but it's a solution that we have that with the cascading, with the BLDC compressors and low starting current. We can provide higher outputs.
Now,
I would. Sorry, Nathan,
no, go on, Ben. Well,
What I would say is, if you've got a client who's got it's a new build house, and they're talking to they still haven't got the power supply in, and it's a big house. There are benefits to having having three-phase. So that's
it
the
gives you
time to put
options.
it in.
It gives you options. If you can get it in, three-phase definitely does give you options.
It gives you more efficiency. The units will be a little bit quieter, and like you say, Nick, it does give you options, and it will give you more reliability. The DNOs, I think, will start advising people to put in three-phase more. They will be encouraging people to put three-phase in, because by people using single-phase, it's giving them big problems of unbalance, because they're getting unbalance of the voltage on different phases. They generate in three-phase. They transmit in three-phase to your local transformer, and they only then split it into single-phase at the point of connecting to the houses. And they try to balance it up so they get the same number of the houses on each phase. But that doesn't mean that people are going to use the electricity all at the same rate. And this is causing them big problems. And if the voltage drops on one phase, they've got to cut the whole lot.
I was just going to add there, with regard to your comment about encouraging. We are aware of some sites some trial sites where they are fitting three-phase to the whole sites on new build properties.
I think this will become the norm.
Yeah, and that's with the new houses using heat pumps, utilizing PV and EV charging. And that does give a lot more options in, and they're going to be carrying out some studies to understand how that network, how everything's behaving together on the network with everything having three-phase.
Because the other thing is PV that we haven't mentioned. If you've got single phase, you're limited to 16 amps, which is 4 kilowatts of panels on your roof. If you've got a big house, so you've got a bit of land and you want extra, you can't go above 16 amps. But if you've got three phases,
cut off,
you can do 16 amps per phase. So you can put a bigger PV array on.
Can I just, if someone wants to upgrade to three-phase, what sort of money are we talking?
It's a difficult one because it depends on the situation. For myself here in my house, it would be very much because I've got a pole in my garden which has got three phases going to it. And I think the cable that they've put in has actually got the wires running through it. So it's just a three-phase meter for myself. But for a lot of domestic urban houses where they've got a single-phase supply going underground, they're going to have to pull in, if they can, draw in a new cable. If it's quite a new house where they put it in a duct. But 20 years ago, they weren't putting ducts in. They were just putting the cable in the ground. They were just laying it in the ground. So you'd have to dig the ground up, put a new cable in, take it to the house. So that's going to get expensive.
We've had feedback from clients over the years of huge variations in costs, from a few thousand up to hundreds of thousands. Yes. It really does depend how far the three-phase is away from the property. Crossing other people's lands, digging up roads, all scenarios.
It's something people need to look at this before they go too far down the route of a heat pump. It doesn't mean it's a non-starter. It means you know which way to plan your installation. But it's something you should look at right at the very beginning. It's something I've always encouraged people to do.
This is what I think may be putting some people off, you see, Bill. The fact that, that they might need to have three-phase, and then they think, oh, well, I'm not going to bother, then I'll have a new gas boil or something like that.
It's more to do about the other technologies as well, though. If you just want a heat pump to run on its own, single phase will be fine. But if you do want to have PV and generate surplus and export that, and if you also may want an EV charger as well, then three phase will give you more options.
And what about batteries? So we've got this battery playlist going on YouTube now. If batteries are starting to go into people's homes as well, how does that change the whole scenario of whether you need three-phase or single-phase?
Not sure.
Yeah, well, the batteries can be standalone, and I'm not an expert in batteries at all, but I'm aware that they're able to cut the home supply off from the grid altogether, and allow if you do have a PV system that is 5 kilowatts, for example, you can export 3.6, and the surplus can be stored in your battery, and so on and so forth. You can store that energy rather than exporting it all, and it, again, gives you options. But I'm not sure if this, you have to have a battery per phase, I think, with 3-phase, Bill.
No, I think you'd have a bank of batteries.
Some domestic.
If you were doing domestic, well, if you're using batteries in the domestic situation, it's the inverter which does the splitting of the phases. The batteries are all batteries because they're DC. So DC doesn't have phases. You just have plus and a minus. So your battery feeds into your inverter, and your inverter is what provides you with the AC current coming out of it. So if you're on 3-phase, you get a 3-phase supply going to the inverter to charge your battery, and when it comes out the other way, it comes out as 3-phase. If it's a single phase, it's a single phase inverter. So it's the inverter rather than the battery.
Yeah, we're going to be talking. We'll be talking some inverter stuff when I speak to the battery people. Now, Phil, I want you to answer this question, because this is another biggie when people are talking about climate change, the environment, and where are we going? Are we going to go H2 down a network? Are we going to go heat pumps? No one's talking about solar thermal as much as I like, which they should be doing because it's free energy. People say that the network, the grid, the electric grid can't cope with all the heat pumps that we potentially want. Now, what is your answer to that?
I think that's a load of rubbish, because for them to state that, I'd like to see their evidence. Because from my experience, houses that you start considering for heat pumps are often powered by oil or coal. This is currently. They're usually powered by something, if it's not gas, but they'll also have backup electric. And from my experience, a lot of the houses where I've installed heat pumps that are off the grid, they've been using more higher power electric to provide them with the backup than the heat pump uses. So inevitably, what happens is the heat pump goes in and they reduce the electricity consumption. It doesn't increase it. If somebody's got a coal fire, open coal fire in the house, they don't want to light it. They're expensive, and they don't heat every room. So they usually have a fan heater or
electric heaters.
They're using electric heaters at times in between lighting the fire. And so they're using the electric. And so the electric actually drops when they put a heat pump in, doesn't increase. But they need to look at this. They need to record it and look at the evidence.
Is anyone doing that?
They don't appear to be doing that. My evidence is merely from what I've seen, from my experience. And I don't know whether you've come across the same thing, Nick.
No, we've questioned this for a long time, and whether the DNOs are used. They've obviously got a maintenance program to upgrade their grid as they're going around the country.
You might think that.
well, yeah, they might, but we have often queried, the cost to upgrade the line when exactly the scenario you mentioned that. We believe we would be reducing the electrical consumption because we're taking, night storage heaters out and fitting a heat pump.
Exactly.
And how is that going to cause more disruption on the network? We often.
I've often thought that they're just looking for somebody to pay for the upgrades.
Exactly. They are private companies at the end of the day, and if they can pass the cost on, that is something we have.
Yes, they're looking for a revenue stream.
Yeah, yeah.
Now, there's another thing that they've realised with EVs is that they can use EVs to balance their grid, because they're looking at using the batteries in EVs to charge back into the grid,
Yep.
which they see as being to their benefit. They can't see any benefit of heat pumps. They just see them as being a revenue stream when they're connected. However, when you put it together with smart meter and time of use tariffs and energy storage, you can treat them as a battery, because it's not electrical energy, but it's heat energy. So you store up the heat generated by the heat pump when the renewable electricity is abundant, and you use it when the peaks are high, rather than using the heat pump. And that can be connected through smart devices, smart meters, so you maximize the use of renewables and minimize the effect on the grid when at the peak times.
This area is super interested, and yeah, we've been working with the guys over at Homely Energy in integrating directly with our controller, to rather than like a simple on-off relay activation of our heat pump, they're directly controlling the compressor speed, the requested water temperature, to charge the buffer tanks if there is one, or to charge the hot water cylinder up to the maximum possible temperature. Because if the electric is free, it doesn't matter if the COP is 2.5, if the efficiency is low, because as you said, we are storing that thermal energy in the buffer tank or in the hot water cylinder, or with using the weather data as well, preheating the house, for example, on your scheduler. And there is considerable logic in doing this, and being able to directly control the heat pump gives a huge advantage in really fine tuning the amount of cheap or free electricity we can get.
I just want to pick up on something there, Nick, just for the people that advise me on social media, because I don't know anything. So you mentioned Homely, and I will be speaking to Homely tomorrow. I'll be doing, because I know Carlos.
Okay.
Wonderful guy. I'll be speaking to him. I'll be speaking to Jan again, Rosenau, and also Peter, a good friend of mine who lives very near me, who's helping Homely with a bit of their coding. So it's very, very interesting technology. So what I'm doing is basically, if you're watching this video, make sure you go and watch that video. I'll probably have Homely in the title, because that's very exciting technology about how all this. I mean, I'm very new to all this. I'm very new to how the electrical grid works. I mean, it was actually Carlos who actually explained it to me. The whole fact that it's like a stock market going on every half an hour, and then something happens at 4 p.m. Very, very, very interesting. So basically, I think what we can say is that, Bill, you think it's a bit of this misnomer that the electricity grid can't cope. I want to bring in something that I always sometimes see people discuss, is baseline electricity. And as we know, we've got nuclear power in this country that I suppose is providing our baseline. And there's a lot of people that say we always need nuclear. Now, I know that I just don't like the sound of nuclear. I don't like the idea that all our future generations have got to look after some waste. I just don't get it. And Bill, you know a little bit about this as well. You don't like nuclear either, do you?
It's the least worst option. It's not as bad as coal, but and we've got it. But I'm not in favour of building any more nuclear power stations. I think we should just let that die off naturally, and look much more at renewables and storage. That's where it's got to be the way forward.
And no, we don't worry about your bell. We're only on Zoom. So you've got this other.
My wife's home with shopping. She wants me to help her.
Well, I'll tell you what. Then we could actually we're going to come back. Obviously, this is maybe spliced into another part 2, and we're going to be obviously do lots and lots and lots. And I'm also going to be meeting Nick as well. So I'm going to end it there. Thank you ever so much, listeners. Follow, subscribe, do all that sort of stuff. You can find me on Twitter at BetaTeach. And once again, thank you very much to my guests. And I'll see you soon. See you guys.
Thank you. Thank you, Nathan. Thanks, Nick.
Yeah, thank you, chaps.